Right. Hey everyone, how you doing? It's Denham-Parry here, as you can probably tell by my name, Betsvea, from Edera. And we're going to get started on this webinar in a couple of moments once we just have everyone join in. So the webinar is on hardened runtimes. And to start, I'd just be interested if you could share. I can hear a little bit of reverb on me there, so let's just check that. Cool. Share not where you are today, but where you're running your workloads today. It doesn't have to be the data center itself, or it could just be under your desk. It could be somewhere on the East Coast, West Coast. Again, which coast? I don't know, probably in the UK. But yeah, if you feel free, find the chat and start any questions in there. But we'll get started in about 1 minute's time. Right, I can see more people are joining. We're going to get started in about 30 seconds. So thanks for coming today. Please make sure you got the chat open. We'd love to take some of your questions later on. And yes, we'll get started in about 10 seconds, I would say. Cool. I feel we're at quorum, so let's get cracking on. Before we do that, let's just do a technical test. Can you see my slide deck? Which would be fantastic if you can. Cool. Oh, right. Just to say to Edera events, it looks like the chat's disabled. So for the attendees, so if you could have a look at enabling that, that'd be fantastic. Cool. Anyway, I'll get started whilst figure out the chat. But hey everyone, I'm Denham-Parry. I'm a staff solutions engineer here at Edera, and today I'm going to be talking to you about hardened runtimes and how we're going to get that era started now. Let's have a look at our agenda. So we're going to be putting a poll down. This poll is just to see which runtime you're using today. Please feel free to share what you're using, and we'll share the results with you after this webinar. We're going to go into some slides. We're going to go from a high level into understanding what the hardened runtime is. And to do that, if you've met me before, you'll know my love of analogies. So we're going to use analogies specifically for that. We'll go into a couple of diagrams. Now, this is where we'll start going a bit deeper into the tech, better understanding as to what a hardened runtime is. And we'll show a quick demo. This is going to just show some of the isolation that we offer today with our hardened runtime. And throughout all of this, we hope that you're going to be passing through your questions. And so then at the end of this webinar, we're going to have a Q&A with Zenla, who's the Edera CTO. She is the person that came up with this Edera runtime. And so learning a bit more about their experiences and how she sees Edera today and where we're going tomorrow. So with our slides, this analogy, if you can see the spinning top, you might figure out what this is based on the Christopher Nolan film called Inception. Hopefully you've seen the film. If you haven't, the main thing to be aware of is it's about dreams within dreams, and it's about people accessing other people's dreams to take memories or to plant ideas in there. I see a similarity here between those concepts and containers today, and that's where we're going to build from. So let's get started. So if you have seen Inception, you know the unsettling feeling of not knowing whether you're in a dream or inside someone else's dream, who can see you and who can influence you. And that's exactly the challenge in container security today. Without hardened runtimes, the lines blur. You don't know if your workload is truly isolated. You don't know who can watch its memory or slip an exploit onto its foundation. Traditional containers all share the same subconscious, and that's the Linux kernel. If one process exploits that shared state, everything built on top of it is at risk. Edera Protect changes that. it creates a lucid prevention-first perimeter at the runtime level, so your workloads run in a reality that you can trust. But before we go deeper into that, let's look into the problem that we have today a little bit further. Now, there has been an influx of tools available to assist us in monitoring what has happened within our containers. But these detection tools are too late, as the event has already happened. We also find ourselves buried in noise. Recently, I've read that we've moved from a time of finding information as a needle in a haystack to a position of trying to find information as a needle within a needle stack. The point being, it's really difficult to distinguish which noise is positive good noise, but also what noise are false positives. It leaves us feeling uncertain today, and we're still in a position of being based on detection and not prevention. So the solution to that is the hardened runtime. Edera Protect launches a new category, the hardened runtime. Each container runs inside its own hardened zone with its own kernel. That's sandboxing at the infrastructure level, not just a policy on top. With sandboxing built in, the attack surface shrinks dramatically. No kernel sharing, no unconscious leakage between workloads, just clearly defined boundaries. How does this work? Well, let's go to Inception for a moment, because in Inception, dreamers carried a totem to test reality. That spinning top was a totem. Hardened runtimes is that totem for workloads. Edera uses a Rust Type 1 hypervisor to isolate containers into their own sandbox. These zones start almost as quickly as you'd expect any container to, but unlike other container runtimes, they eliminate the shared kernel attack surfaces. It's prevention through attack surface elimination. So drivers, GPUs, networks, and storage are separated. So a flaw in one can't cascade into another. To this, we get instant containment. In a dream, you sometimes only realize something is wrong when it's too late. Traditional detection tools work the same way. They flood teams with alerts after the damage is already done. Edera flips that. The hardened runtime enables instant containment. If a workload steps outside its allowed boundaries, the runtime can gracefully pause it, isolate it from the network, or lock it down immediately. No alert storms, no chasing ghosts, just lucid control of your workloads. So today we find ourselves with AI and GPU workloads. AI agents are like dream architects. They can generate code, they can act unpredictably, and shape their environments. GPUs make those dreams faster and more vivid, but when shared, they also multiply risk. With hardened runtimes, every AI agent and GPU job runs its own sandbox. Memory access and device permission are explicitly authorized. They're never assumed safe. That's sandboxing applied directly to the most sensitive, high-value workloads we're running today. So the bigger picture with Edera. In Inception, the key was regaining lucidity, knowing which layer of reality that you were in. Edera's hardened runtime does that for cloud workloads. By combining sandboxing, attack surface elimination, and instant containment, it creates a prevention-first model for securing AI and cloud-native applications. Not a dream, it's not guesswork, it's a runtime that you can trust. So this is our final slide for this slide deck, and I'll leave you with this. Are your workloads dreaming within someone else's dream, vulnerable to influence that you can't see, or are they running in a hardened reality where you control the boundaries? Hardened containers with Edera Protect bring lucidity back to runtime security. So from this, we'll go into some diagrams now, and we'll get a better understanding as to how Edera achieves this. Now, I've been working within the industry for the industry being with Kubernetes for about 10 years now, and this diagram keeps appearing. So at the bottom, we can see hardware. So this is everything physical that's in our data centers. And to be able for our software to work with the hardware, we're defined at this moment by the host OS kernel. This is what interfaces between the two. On top of our host OS, we can see that we have two containers running here. Containers have processes running inside, and they have their own guest operating system. Now, over time, there's been one thing about this diagram that I don't really enjoy, and it's the solid lines. Again, through the last 10 years, I've been focusing more and more on security. And when I see a solid line, I think of that as a solid security boundary. So when I first came into containers, I assumed that isolation was already there, that was already available. I thought that was one of the features of it. We can see here that we've gone from a solid line to dashed lines. Now, there is still that solid boundary around the perimeter, but underneath the hardware, we see a dashed line. And again, that's by design, because our workloads do need to interact outside of our machine. Similarly, with a host kernel, there's dashed lines there, and with our workloads. The problem that we have is that they're so porous, there's so much space between there, that not only are the workloads that are expected to work in that fashion available to do so, but we also find vulnerabilities. This is where we find bugs, and this is where we can find compromise. So we might not expect one container to be able to see into another. And we might think that running containers side by side might have its secrets hidden away, or it might not be influenced by another. That's okay, but when we start to talk about scale, when we start talking about running software as a service, where we might have two customers who are competing in the world, they might have workloads running side by side. What happens if those two workloads can see each other? We've also made this more complex nowadays by adding, well, GPUs into this. And this isn't just GPUs, this is hardware in general. We've always had this, but now we're at this juncture where there's so much focus on AI and utilizing these GPU devices. This is exceptionally just causing more and more concern. So to solve that, Edera starts with a clean slate. We still have our hardware, but on top of our hardware, we have Edera Protect. That's our type 1 hypervisor. On top of Edera Protect, we have the Edera Protect zones. So we can see that these zones are running containers, as we saw in the previous diagram, but each of these has its own guest kernel. If we zoom into this zone, we can see that containers are still exactly as they were. We haven't rebuilt the containers, we haven't changed any of the code in there, we haven't changed any of the libraries. These are exactly the same as to what we previously had. The difference here is around the containers. The difference is with the Edera Protect zone, we have a solid line. There's a solid line, all but for a small part in the bottom that interacts with the guest kernel. Now, in that small section, we know exactly where we should be communicating between those two layers. So that allows us to focus cleanly and explicitly as to where these things, what's coming in and out. Finally, back to that noise, we can reduce the workloads within that zone. So there's less things coming in and out of our zone. So that allows us to reduce that noise. Finally, when we look towards GPUs, we're able to pass the GPU directly into an Edera Protect zone. So in this instance, the Edera Protect zone on the left has access to the GPU device on the machine. The zone on the right is completely unaware to that GPU device. That's what's providing the isolation that we need today. So with that, we're going to go into a demo. And for that, I'm using Demo Magic to help me type. And we're going to have a look at isolation. So to look at isolation, we're going to focus on using one node. So we've only got one machine here running the workloads. And we're going to show the problems that we have today. So we're going to run a pod called Leaky Vessel. And what is Leaky Vessel? Well, it's a very simple pod. It's very simple by design. One key thing to note is that we have an environment variable in there, while the super orchestrator secret. And the other part to note is that the workload itself is just a sleep.shell file, and it's just snoring out to the logs. Now we're going to apply the Radar. So the Radar is another pod. And if we look into what Radar is, well, again, it's fairly simple by design, but there are two key things that are of a concern to us. The first concern is that host PID is true. This means that the host processes running on the machine that's running this container, those processes are available within that container. The second concern is that privileged is true. Concern here is that any security defaults that we have just been thrown out the window. Because of that, and because Leaky Vessel and Radar are running on the same machine, we can start out this attack. So we're able to, from Radar, see all processes that are running on the machine. And now we're going to look for the leaky vessel process ID by using some bash. We're finding this by searching for the sleep.shell command from the processes. So that's given us a process ID. And now that we have that process ID, within Radar, we're able to see the environment variables within the leaky vessel container. Now, the concern here is that a secret is a secret until it's run in memory. And so we can see that we have our super orchestrator secret that we had within the YAML, but we also had another key that was baked in called a secret key. So from Radar, we've been able to go into leaky vessel and to see the secrets that it has. So we can solve that problem by, first of all, deleting leaky vessel. But that gives us the other problem that we're not actually running the workload. So we're going to fix this. And first of all, we're going to apply the Edera runtime. And now we're going to apply the hardened vessel. So if we look at the difference between leaky vessel and hardened vessel, other than the naming changes that we have, there's one key one here called runtime class name Edera. So what we're doing now is that we're running the exact same container in a pod, but this time it's using the runtime class of Edera. And just to ensure, it is still snoring out, so it is still working as expected. But we're going to replay the attack through Radar. So we can see our processes there. But we can't see leaky vessel anymore. The reason we can't see leaky vessel is because of this design. Is because we've put now what's hardened vessel into its own Edera Protect zone, and Radar is separate to that. So Radar is unable to see what's happening within hardened vessel. We've been able to do that without rebuilding the image. We've done it just by amending one line of YAML to put runtime class Edera. Right. So that finishes our demo. So now I'd like Alex to join us if possible.
Hello.
Hey, Alex. So thanks for joining us today. If you wouldn't mind, could you give us a bit of an introduction to yourself?
Yeah, hi. I'm Alex Zenla, the CTO of Edera. I spent a lot of time in the Internet of Things industry, about 10 years, and worked at Google on IoT and IoT security stuff, and uh, started Edera with our co-founders, and it's been a lovely journey thus far. And I especially love technology. You'll find probably some of the passion in my voice as I talk about some of these topics today, but excited to chat.
And so Edera Protect was your brainchild. It's and it probably like 16, 17 months ago now. Where did you see the problem within the industry? Why did Edera Protect have to come into being?
Yeah, time doesn't make sense anymore. So it's somewhere in around 16 to 17 months. I'm not for sure. Um, Edera started out as a project that I was doing in my free time. Um, Anyone who knows me knows I really love computer history, and I also love deeply technical problems. Uh, One of the challenges that I had in my day job was I was trying to run multiple different workloads from different tenants on a single piece of hardware. This is a very hard problem to solve, especially at the time. And being Google, we looked at things like gvisor and Kata, but they really didn't solve the problem for us for a variety of reasons. One of them being that Kata requires hardware virtualization, the other being that gvisor is has a huge performance penalty. Um, but multi-tenancy is critical to almost every application out there, honestly. If you really look at any application that companies are deploying today, you are using multi-tenancy in some fashion, almost guaranteed. And we were no exception at Google. And the problem that we faced is we needed to we only had a single piece of hardware in each one of these buildings where we were doing IoT monitoring. but we needed to run different people's software on that single device. And there was really nothing out there for that. So Edera was this project to say, what if we looked at computer history and just changed how we ran things? If you really look at the computing industry over the last 20, 30 years, well, I would say in the last 20 years, things have been not that different, actually. Containers have really taken over the world, but the way we run workloads isn't that different, aside from, we run it on someone else's computer more often now. There's this thing called serverless, and then you have Kubernetes. But at the end of the day, it's all a process on a Linux kernel. We've been doing that for the longest time. And Edera is really all about changing the game there, thinking differently about how we isolate and separate things, and really making segmentation of workloads and concerns native to your hardware. Um, so Edera was this idea of taking this concept of the type 1 hypervisor and converting it and flipping it on its head. No longer do we have to run, a big giant Kubernetes node inside of a VM and then just run all of your processes together. Now you can actually create zones, which are like virtual machines, but super lightweight, that can isolate and segment workloads. Um, and this technology, very quickly, I realized that this was something that could apply to a variety of industries and really fundamentally change how we think about containers today.
Yeah, it's my journey into this as well. I'm a completely different path from you, but I found myself with containers, and like I mentioned during the slides, it's this basis of I was an application developer, and so it's just ship it into this container image, and then it'll go somewhere else and it'll be isolated. It does all these things for you. And the deeper I've gone into it is more and more understanding that actually I don't necessarily wish, sometimes I look behind the curtain, but I have looked behind the curtain and then I've seen all these issues. And coming into this webinar, I've been trying to understand better about where we are as an industry. And I've gone through a couple of these cycles where it feels like we fan out. We scale out and we go into our silos and we scale back in. And coming into this is this understanding that there are so many different roles now, especially within the cloud native system. And it doesn't necessarily have to be cloud native, but let's use cloud native as an example, where we've got application devs and we've got infrastructure and we've got a myriad everywhere in between. And we're all going in these different directions, but we're also like, again, these advancements and so forth, but we're kind of siloed from each other. And the beauty that I see with Edera Protect is that we're isolating it at the pinch point. We're focusing at this one level, and then everything else underneath it gets the benefits from it, because as well as that security hardening that we're looking at, we're also seeing performance gains. So maybe how have you found getting this performance to be as performant with a default container runtime that you might have been using for the last 10 years? How can Edera Protect offer that level of security, but also that level of performance as well?
Yeah, the security aspects were always the key thing, but I recognized early on that no one would adopt a technology of this sort unless it wouldn't sacrifice performance. And I think that's a key insight that people forget when they're going out and building these types of things. So we really focused on performance early on, and the performance of Edera Protect is all about being so low level. We're so close to the hardware that we can do things that other people haven't thought about or haven't been able to implement because of problems like nested virtualization. Your Inception analogy is a really great example because we often see people do things like Docker and Docker, where they're running a container runtime and a container runtime. And this has a really rough security profile, but people do it mostly for performance. And I see that as a significant limitation of existing container systems. So our technology is really highly performant because it interacts directly with that hardware. Um, and we utilize low-level technologies in order to be able to do that. We're within 1 to 2% of performance impact on your workloads. whereas other solutions out there are often 20%, even sometimes 30 to 40% impact.
And just for the people attending today, I believe our Q&A section is available. The chat is not available, but I believe there is a way to submit questions, so please use the Q&A function. Yeah, and thank you for the inception. It's just how my mind works, and but it's this concept of layer upon layer, and it's got us to this stage so far, but it's also that concern of having so many layers deep, as well as the security about then if you intercept one level, then everything built on top of that is completely vulnerable. It just takes a bit of performance away at each time, at each point. But it's back to this, when I've mentioned cycles, I see parts of Edera leading the way. There's brand new things that we're finding and learning and bringing towards Edera Protect. But also there are some fundamentals that we see repeating, and it could be based off, say, the type 1 hypervisor that we base this off. So would you share a little bit about your experience? Because for me, coming into this, I must admit, I had an idea as to what a type 1 and a type 2 hypervisor was, but then I remember asking you on our first day if you could give me the definitive, and I believe you said it was complicated, and I still believe that is to today. So, so my question to you at this moment is just, what have we based the Edera Protect hypervisor on, and what are those differences?
Yeah, great question. And this is something that comes up a lot because there's a lot of interesting complexities around it. But I also think it's a question that's simple and complex at the same time. And I think we accidentally made it complex in the industry. So our technology is a fork of Zen, and we've re-implemented a large portion of it in Rust to modernize it. I'm a computer history nerd, as I lightly mentioned earlier, and I knew about Zen, and it kind of like kicked off truly the cloud computing industry, arguably, right? Like AWS was based on Zen for a long time. And I think that we have a tendency when things are older to kind of like push them aside, and we always are in tech chasing the new shiny thing, but we never really look back at like what we left behind and how we can modernize it and bring it to our new goals, because computing goals are always constantly changing. um, and it's an interesting thing because we started out in the world with type 1 hypervisors. Like that is the way that we conceptually thought about hypervisors early on. If you ask someone about a hypervisor, say, 20 years ago, what popped up in their head was this idea of a type 1 hypervisor. And that's a very thin layer on top of the hardware. And then from there, you run individual virtual machines. Like the point is that the bit that is doing the virtualization is only and truly only responsible for mitigating or providing a middleman between the hardware and what you're trying to do in your workloads. Um, Type 2 hypervisors, however, kind of integrate the hypervisor in with an existing system. And this is simpler from some aspects, but it also has a really big problem. Type 2 hypervisors like KVM integrate your host system and your applications with the stuff that you are trying to virtualize. This increases the attack surface significantly. So for example, in a KVM-based architecture, you might be running kubelet or the Kubernetes kind of daemons directly on the host, and then you are running virtual machines on top of that potentially. And so you have that problem where the layer that's doing the virtualization is a lot heavier than it should be. And any system that is using KVM today is currently deploying a full Linux kernel in order to do that virtualization, which brings a huge amount of attack surface. So our focus has been really on reducing that attack surface with a type 1 hypervisor, which is only responsible for virtualization. It truly only is. We're talking the Linux kernel is tens of millions of lines of code. The statistic changes every day because it's a fast moving target. Whereas Edera's hypervisor, the fork of Zen, is hundreds of thousands of lines of code, much smaller, very much smaller. And a lot of that is compiled out as well. So we're talking even smaller than that. And I think that's a really important fact because every line of code is a line of code that brings risk to you. And that is what we're able to eliminate by having a smaller hypervisor being deployed on the hardware. It also allows us to do hardware tricks that Linux can't do for reasons that are complicated, but basically boil down to Linux is trying to do too much. It's trying to service too many things at once. And you got to remember, Linux is a monolithic kernel. Everything runs inside the kernel, inside the same process. Right. It effectively is just physical access to the memory at the kernel layer.
Thank you. And we've got a couple of questions that have come through. So I feel like now is a good juncture to answer some of these, and then we'll also then push on because the final question that we've got so far helps us move on to that. But what are the dependencies to run Edera Protect? Does it need specific kernel, distro, or CNI?
It needs none of those. All you have to do is deploy your hypervisor below your host system. And the reason for that, and the reason why we went with that, is because we can move our technology below the kernel and really reap the benefits of that security of that type 1 hypervisor. And if we asked you to patch your kernel, and by the way, one of the original reasons for going with Zen is that Zen is already upstreamed in the kernel. We don't have to go and make a big upstreaming of changes. And anyone who was around for the early days of eBPF, for example, will know that to get eBPF you had to have patched kernels. I think that would be the wrong decision if we required patched kernels. So our technology was really designed to integrate with the existing Linux kernel as you are using it today, which is super powerful. In terms of the distro, we do not require any specific distribution. Our technology deploys and interacts with the hypervisor through hypercalls. So as long as you can deploy our technology in some way, as in run something on your host system, you can access the hypervisor. And we support a wide variety of CNIs. We actually have a lot of in-house expertise on CNIs. We have full compatibility with the CNI spec. So the answer to those is none of those are required. You can also run these on public cloud. So you don't have to run these on-prem. You can use your existing public cloud solutions, Kubernetes solutions, and integrate directly there. So for example, if you're using Elastic networking CNI and all of those, that totally works as well. So yeah.
And with that as well, just to follow on a bit from that question, the implementation of it, because during that demo, I showed that we just changed the runtime classing to Edera. Is that how you see most implementations with like existing clusters, and that you can spin up nodes for like running Edera Protect and then just change your runtime classing? Would there be anything else that people would have to focus on, whether that be within their containers or within the YAML?
By design, no. And I think that's a very important point. If we required you to change how your workload works, I think that would be a disservice to your team in adopting a technology like this. So we really focused on the ease of use and that one-line change. So when you adopt the Edera runtime class, that Edera runtime class is serviced by the Edera components. The Edera components will spin up your pod in a secure way. I think that's a really important point, that our compatibility with existing containers is really important. And one thing I want to touch on as well in that is that containers that would actually be super insecure without running on Edera, for example, a privileged container, where you do security, I believe it's security context privilege true. That is like the big killer, right? And the Kubernetes world that allows you to do a lot of dangerous things. If you apply the Edera runtime class, that eliminates that risk entirely, because now you're only privileged inside your zone, and your zone is only for that Kubernetes pod. And so you can get privileged access, but only in that zone, which isolates and prevents any lateral movement or attacks that you could do with that parameter. So most solutions to disabling or not allowing privileged containers are policies that just define don't do this. But what if your container could do that, but safely? And that's what we've been able to do with Edera.
And the ever exciting thing I see here is that I've come from a background of us having to change our containers. We've had to rebuild them to meet certain standards and to be able to get them into production. But in seeing that path, I've also seen the path where, for whatever reason, people haven't been able to rebuild these containers. And they're still running them in production in environments where the CVEs are astronomical and so forth, but there's nothing that they can do because they can't change the container itself. Whereas with Edera Protect, we can put a wrapper around that instead. And even to the point of we can specify the kernel within that zone to specific, because it's usually dated at this point. So we can really meet that container where it's at and then secure it. So then it's almost like a best of both in that scenario, which comes to a Swiss cheese model, which you can chat in a moment. But there's another one, there's another question here. So can Edera reduce the volume of my security alerts? Yes, because we can reduce those workloads within that zone, so you can then focus your alerts specifically on that zone. But I'll pass to Alex as well. Is there any further insight into that? Fine.
Yeah, I think it's very important that when you look at a lot of the security alerting mechanisms that are out there, um, a good half of the rules are actually related to, does this container touch the host? But here's something crazy. Edera doesn't let you touch the host. So we can effectively eliminate a large portion of your security alerts, or as we like to say, can recontextualize them. So you can say that now this security alert is an info level instead of an error or a major sev zero type of problem. And I think that's very important because people, there's sort of this interesting thing where security alerts almost act as like an observability thing for some people. And we can still provide that observability with our integration with eBPF and other tools like that, where you can still use your native tools that you're used to and adopt our platform and still get that visibility. But you can now not have to freak out when you get a major alert coming in. And I think that is super important for security knocks and things like that. And I think it's it's also key to understand that reducing the security alerts is reducing toil on your team. We've talked to many security teams where they're just overloaded and drowning in alerts, and recontextualizing them really gives people the power to still have visibility, but reduce that scariness of those alerts.
Yeah. And that's when I read about the needles within a needle stack, it was whilst I was on holiday, I had the beauty of having some time to go away and read. And it's got to this point, and again, this isn't diminishing where we're getting with the technology. Like tools like eBPF are fantastic. It gives us so much more observability. It gives us so much more information. But we're now finding that problem, and this isn't just in this instance, but in general, there's just so much information that's provided. We can't figure out what's important information and what isn't. They all look like the needle. And so the way that I see Edera Protect helping solve this problem is just by we're just limiting that volume. So then it allows you to take that time, and it's more likely that it's going to work out a lot better. So yes. There's also a question in chat from a maintainer of KubeOS. So heads firmware maintainer and KubeOS user contributor for years on laptops and workstations, unsure why KubeOS are not using same changes. Guesses? I can't guess. Can you, Alex?
Yeah, I mean, we've talked with a few people there, and I think, if you look at the Dara model, in some ways it's similar to KubeOS, but obviously much different because it's about servers and not about your client system. But I think, we're doing something very different in a lot of regards, in the sense that, we're looking at our threat models very differently, and threat models in the server space are different. You have also this concept of not trusting your hypervisor, like the hypervisor that your cloud gives you, and those kinds of things. So there's some unique challenges as well. But I also think that a lot of the improvements that we're making to our fork of Zen do make it upstream. You can go search the Zen repository to find out some of that. And we also have some people internally that contribute. So I think they will benefit upstream from some of our changes.
Thank you. And this takes us, so again, if you do have any more questions, please feel free to. Is Edera using in the manufacturing industry, especially within embedded systems? Oh, sorry, is Edera used in the manufacturing industry within embedded systems?
It plays very nicely there. In fact, if you were there for the beginning for my story of how Edera came to be, it was for industrial IoT use cases, which is exactly embedded systems and manufacturing industry type stuff. For us, it was about real estate and the ability to monitor things in real estate. But I think, it's the same problem space in a lot of ways. And much of my work in IoT has been around the manufacturing industry. I've spent many years in that space. So I think it applies very well there. And we've had some interest in that area as well.
So yes, as we're starting to close, but we've got some more time for a couple of questions, but so please put them into the Q&A if you do have them. But there's one left in the Q&A at this moment. What excites you about Edera over the next 6 months? Now, I'll probably also bring that into a lot of our discussion so far. We haven't really spoken about GPUs. We've shown the diagrams and so forth, but in our conversation with our Q&A, we haven't mentioned that. So would you be able to share more about that?
Yeah, absolutely. I think it definitely is that hardware integration and ability to work with hardware that I'm most excited about. We placed a lot of emphasis in Edera on making it easy to adopt, and a lot of workloads today in Kubernetes don't require direct access to hardware. So getting that right is very important. And it's important to mention as well that workloads that require hardware also, function are basically similar to workloads that don't. But what we've been really excited about is our technology around GPUs and hardware of that sort. And I think it's important to understand that the state of the art today when dealing with GPUs is effectively don't secure them. It's just too complex and you have too much going on, and there's a lot of proprietary software also involved that you can't rebuild and secure. So there's a really high amount of risk. For example, NVIDIA GPU drivers or user space rather is all stuff that you can't recompile. And the risk is extremely high with that stuff. And so Edera zones perfectly work with that. So what I'm excited about most is our NVIDIA support, which we have been actively working on and perfecting. And I think it's going to really change the game here because we're not just doing what Kata is doing with just pass through and you have to figure out all the bits yourself. We're really making an ease of use story for how you adopt GPUs on the Edera platform. So I think that's the thing that I'm most excited about in our roadmap. And hardware is this beautiful thing where you can deliver really great ease of use to use existing hardware if you have the right software. Anyone who's ever worked with new hardware that has just come out knows that the manufacturers tend to make your life hard when you want to adopt new hardware, and Edera eliminates that difficulty.
Okay. And I think it's that difficulty. It's as an end user as well with Edera Protect, it's that basis of just the ease of use of that. It removes all that friction. And again, coming into security over the last 10 years, most of our horror stories are just by misimplementation of having to do XYZ. Whereas again, with Edera Protect, it's at such a pinpoint that it just the release from that it makes it so much easier all around there. So I'm super excited to see that as well, because I'm concerned within the industry the way that we're advancing as quickly as we are, and that's not for concern. I feel that that's just the nature of the beast. Again, another reading I've recently learned was how people compare that. We used to say that memory doubles every year, and now we're saying that business is evolving at a 4-year rate constantly. And those changes are just happening now. And it's this concern of there's so much, again, so much information coming in. Knowing that you've got the secure foundation that can be provided with Edera Protect allows you to focus on those changes rather than having to constantly go back and, like you said, patch up these things because you've got that coverage there. And also the next 6 months, I'm excited because, well, Marina Moore, she's at Open Source Summit at this moment in Amsterdam, but we're pretty much everywhere, it feels, coming in towards the end of this year. So I'm excited to go out and see everyone. So yes, we've also had from Thomas, multi-tenancy is extremely important in the semiconductor industry. Protecting IP while collaboration is extremely important. Love to hear your vision.
Yeah, that's extremely great to hear. I think the semiconductor industry is a very interesting space. And we really believe in privacy and security should be fundamental to computing. So our vision, I think, is truly the future.
And we've had a comment saying that there might be an echo on both voices. We will have a look into that recording, and luckily we got audio tools today that will probably be able to remove those echoes. So the recording will be made available after this webinar as well. So hopefully that will be solved. So Alex, I feel like we're about to close out as we don't have any further questions. So yeah, I guess when you wake up in the mornings, and again, we're a multinational company. I'm based in the UK, you're based on the West Coast. What's the thing that excites you most about Edera each day when you wake up?
Our team and our technology are hand in hand, just the best thing about Edera. We have a really excellent team of people who are working on these problems, and I want to send a thank you to them for all their hard work over the last however many months it's been. So I would not want to forget that. But I think our technology really, I've never been more excited to work on something in my career. I think I'm at 12 years full-time in this industry now, and this is the first time I've really felt like I am doing something at work with a great team that is really changing the game in computing. So knowing that every day that we can make a big impact on the security and privacy and safety of computing is so important to me.
Yeah, I'd echo that. And equally, if you've not heard Alex's story, we have recording, it's amazing, 12 years, and it's phenomenal. Hearing everywhere we've been, and to equally then know you're excited at this moment is amazing. The way that I'm seeing it's this juncture. We're at this point where the solution that we have and what's happening, they just go together so perfectly. I mean, it's not just so much about Edera Protect as what Edera Protect will enable. It's going to enable so many safer things to progress, and it allows us to run at the scale. It's I'm super excited to see people continuing to use Edera Protect and how they're using it. Right, I feel that we're at time. So Alex, thank you so much, and thank you to the Edera team for helping us organize this. And I believe we'll have another webinar in a couple of weeks, so please follow us on LinkedIn. I'll share the slides. So those are some useful links. You can see our site. We have lots of stories. We're constantly updating and we're constantly sharing, so please feel free to follow our stories. If there are any questions that you have, please feel free to reach out to us directly. There's a little hack as well. If you want to find me, I'm quite easy to find thanks to my surname on the internet. We've got our LinkedIn, so please follow along to that. Again, we've got a webinar that we're going to be announcing quite soon. That's in the not so distant future with some exciting guests. And finally, our Blue Sky as well. So thank you everyone for joining us. And equally, if you're in the future, thank you for watching us. And yeah, looking forward to seeing everyone soon. So cheers.
Thank you.